Hello students. So now we're looking into more about what our calculus can tell us about the curve. And so we're here in 6.3 and we're going to look at ideas of points of inflection. We're going to talk about concavity and testing for maxes and mins. So let's look and delve into inflections and shape. So if we think about curves and graphs that have curves, we can label those curves as being concave up or concave down. And generally, when we have the shape that's sort of like a cup, this is concave up. When it looks more like a mountain or a hill, this is concave down. But here's our formal definition. So our formal definition depends on where the tangents lie. So if I look at this curve and drew in tangents at each integer point. So for example, here's an integer, my tangent would be here. And then my next integer, I've got a tangent here. Notice here's my 0, but here's my integer tangent value. So this one's pointing with a negative slope, more negative. Down here, now for this integer value, maybe I'm at this point, and here again, I've got my tangents. This one's 0, tangents here, and we continue on. So my formal definition of concave up is when the tangents are all underneath the curve, or if the curve is above all of its tangents. Concave down is when the curve is underneath all of its tangents. So notice there's going to be some point around here where we switch concavity, where we stop drawing the tangent on top and start drawing the tangent underneath. So that point where the concavity changes, so in this curve, it looks like it's going to be somewhere around here. This is our point of inflection. And that point of inflection is when the tangent would be right on the curve. So not over, not under. So this is our point of inflection. My intervals for concave down. So I am concave down if we're thinking of these as integer values. Here we've got -6, and it looks like we're switching somewhere between -1 and -2. So for sure, I'm concave down between -2 and 6, and maybe, I don't know this exact value here, so it's somewhere between -2 and -1. So I'm just going to call that point A. So I'm going to be concave down for x less than a, assuming that my graph continues this way. I'm concave up for x greater than a, and the point of inflection is at x equals a and whatever the y value is there. So again, our tangents are above for concave down, tangents are below for concave up. When we're looking at concave up, notice that my slopes of the tangents are going to be positive and negative. So my first derivative that just tells me the slope, knowing the value of the first derivative or the sign of the first derivative doesn't really help me so much. When I'm looking at concave up, it's the same thing. I've got slopes that are going from negative to positive. Here my slopes are going from positive to negative. So I can think about this way. For my concave down, my slopes are decreasing. I'm going from positive to negative. So for concave down, my slopes of the tangent are decreasing. For concave up, I went from having a negative slope to a positive slope. So the slopes of the tangent are increasing. At the point of inflection, I went from decreasing to the point where I started increasing. So at this point of inflection, that's where my slopes stopped decreasing and started increasing. Or similarly, stopped increasing and started decreasing if I went from concave up to concave down. So if I think about what's happening to my slopes here, they're decreasing. This means that the second derivative must be negative. This means that the second derivative must be positive. At the point of inflection, my second derivative must be 0. So here we've got our way of defining by looking at where the tangents are, but I can also think about defining in terms of the second derivative. So if my second derivative is negative, I have concave down. If my second derivative is positive, concave up. Second derivative is 0, then we probably have a point of inflection. So if it's concave up, then f prime of x is increasing, and the second derivative is positive. Concave down, we're decreasing. And you could always give yourself a little sketch. Concave down, positive slope, 0 slope, negative slope. That means we're decreasing. Second derivative is negative. Point of inflection, f of x is switching. So at that moment, it's stationary because I'm going from increasing to decreasing or decreasing to increasing. Hence, the second derivative is going to be 0.